Hello students, so today I am here again with another problem, another topic you can say, that is section of solid. If you remember, last time we started discussing about section of solid and what is the need to section any given solid to maybe to gain knowledge about some of the internal features of any object, machine part or building or a electrical part. So that is the purpose. And also I have discussed with you about different type of cutting planes used for sectioning of any given solid. And last time, if you remember, we have solved this problem when there will be a simple right circular cone is there and its base will be on the HP and this cone will be cut by a section plane which is parallel to HP. So when the section plane is parallel to HP, you know that in the front view we will get the line view of that section plane. So we should begin with the front view, the section plane, showing the section plane in the front view, and this will be also the vertical trace of that section plane. That also I have discussed with you that whenever the section plane will be in the form of a line view, it will be either VT or ST. Where it cuts the front view, that will be VT. Where it cuts the top view, that will be ST. So today I want to discuss with you another problem, and also in this figure, this shape, that shape will be generated after the intersection or the cutting of the solid in the front view. That top view, this shape will be the true shape of the section as the cutting plane is parallel to the HP. Now this time I am taking another problem. Suppose there will be a solid like a square pyramid, and again the solid will be placed in such a way so that the base will be on the HP, that is the simple position of the solid, and one of the side of the base parallel to VP. So I have started with the top view, that is this square. If I want to name that, that will be A, B, C, D, and this point will be apex. This will be O dash, A dash, B dash, C dash, and D dash. And this time I am going to use a section plane which is inclined to HP and perpendicular to VP. Inclined to HP section plane which is inclined, suppose 45 degree to HP and perpendicular to VP. So as you know that whenever a section plane is perpendicular to VP in the front view, that look like a line. So I should start with front view, and suppose it will be bisecting the axis of the solid. Bisecting axis of pyramid. So what I will do, that I will mark the midpoint of this pyramid and I will cut it by a section plane which is 45 degree inclined to the horizontal plane. So maybe this will go like this. So this is the figure. If you see this, so now as you see that the upper part will be removed, so this lower part will be remaining with me, remain with us. And as you see that this section plane is cutting the edges of the solid, so I will name those edges. So this is 1 dash, this will be 2 dash. These are the points that will be on the O dash, A dash, that is 1 dash, then on the line O dash, B dash, that is 2 dash, then there is another line O dash, C dash, so that will be 3 dash, and this will be 4 dash. So the concept will be, we will start naming the cutting part from the left to right and initially name those points which are visible, those lines which are visible, points those are on the visible lines. So O dash, A dash will be a visible line, but O dash, D dash will be behind line. So I will name that later on. So from left to move right, then again back from left, right to left. So I will got these 4 points, and all the 4 edges of the pyramid will be cut by this section plane. Now if I shift these points in the top view like this, by perpendicularly coming downside, we can get the points in the top view, and the points are like this. This is point 1, this will be 2, this will be 3, and this will be 4. How can join all these points by the straight lines. As in the polyhedra, the joining will be with the help of a straight line. You can get the required figure. I can color the outer part of the complete pyramid like this. The edges are also darkened, and inside part there will be section lines, again inclined 45 degree to the reference line. So now this way we got the sectional top view and front view of this cut solid. Now as you see that in this figure, this cutting plane will be inclined to HP and perpendicular to VP. So in the top view, what the shape we got, that is 1, 2, 3, 4, that is not showing its true shape. So if we want to find out the true shape, either I have to rotate this complete solid so that this cutting part will be parallel to the reference plane, parallel to HP, or maybe we can generate another reference line, or we can use the change of reference line method, and we can draw perpendicular from all those 4 cut points and mark the distances and plot the true shape. That will be like this. If I want to find out the true shape of this cut part, then one of the method will be, I will draw a line parallel to this cutting plane as new reference line. So any line parallel to this cutting plane, and suppose I will name that x1, y1, and now from this cut part I will draw these 2 perpendiculars on this line, and we will pick the distances from the old top view. So if this will be the distance of one from the old xy, that will be the distance of the new one from the new xy. So for the change of reference line method, the logic will be the distance of the new view, as I am drawing another top view from this front view. So the distance of the new top view from the new reference line will be the distance of the old top view from old reference line. So if this will be the distance of one from old xy, then this will be the distance of new 1, 1, you can say, from new reference line. Same way, if this will be the distance of 2, then I can also mark the distance of 2 from this on this line, so that point will be 2, 1. Same way for 3, this is the distance of 3, so I can mark this like this. Then finally the distance of the point 4. So in this way I can get all the 4 points with reference to this new reference line, and if I join all those points in the same sequence as they are in the figure, we can easily get this will be here, this is 2, this is 3, and this is 1, and this is 4. So I got 1, 2, 3, 4. Just little bit of correction is there, and in this way you can get the true shape of this plane. And again you can draw these section lines inclined 45 degree to the xy line. So this will be the true shape of the as this shape is not the true shape, that will be actually known as apparent section. So this is one of the basic problem of section of solid, when the solid will be cut by a section plane which is inclined to HP and perpendicular to VP. So this method that I have used to find out the true shape, that is known as the change of reference line method, and the simple logic will be, for a change of reference line method, the distance of the new view from the new reference line will be the distance of the old view from the old reference line. As right at the moment I am from this front view, I am drawing the top view, so I have taken the distance of the old top view. Okay, I hope that you will understand this problem, and this is one of the basic problem. Try to solve this. Thank you very much.